This is a test. This is a test to see if I can successfully navigate the stupid YouTube new way of doing things, because now I can't find anything. I don't even know if this is going out live, but here is a view of my microscope. I think it's live. Can I even play my own video? I can play my own video. Well, that's interesting. So that's cool. Anyway, I have a new microscope. And it actually works pretty well. It works a lot better than the other one, which was highlighting, which was blowing out the camera. This is pretty cool. See? You can see things very clearly. I can zoom out. Where's my... Can I zoom? Can I focus? Not... Well, it's... Okay, how about this? That's nice. That's very schmick. So I can inspect things, and then I can zoom out. And there is some... There's a little bit of problem with glare. There's not much I can do about that. But other than that, it looks pretty good, I think. Let's see. Yeah, you can see tweezers. I can point at things. That's pretty cool. I can solder things. I can solder things. I can point at things. I can clean things with a Q-tip, which is pretty cool. I can put my finger underneath, and that's pretty disgusting. Sorry, I'm coughing because I'm in the Bay Area, and there was that fire which has released smoke throughout the area for like the last week or over a week, so there might be a little bit of hacking, and not the good kind. Here's a little thing. Here's a tiny little chip. Let's see if we can read anything off of it. Yeah. It's not really in focus, though. Oh, there we go. So you can sort of read. It's an NXP chip. And unfortunately, it's got some gunk on it. But that works. Here's a printed circuit board. Here's another printed circuit board. I can zoom out. Well, that's about as far as I can zoom out. Which is not that great. I think there's a lens that I can actually remove. Let's see if I can remove a lens. Let's see. Yeah, this is a lens. This is an 0.5x lens, and if I remove it, let's see what happens. Oh, well, I didn't break it. That's good. So what happens here? It looks like everything goes out of focus, so I should probably just put the lens back in. Right, 0.5x, of course, if I remove it, that's just going to double the magnification, which is not what I want. I actually want to zoom out, which would mean that I would have to have either another 0.5x lens or a 0.25x lens, or I suppose I could lift the entire... No, I can't really lift the whole thing up because, see, if I lift, everything goes out of focus, and that's no good. yeah, that's certainly not going to work. So this is about all that we can see. So we can't see like the big picture or anything. So let's see if I can show this. Yeah, wow, that's really bad. So, okay, I guess the microscope is good for really, really close-up work, but I am going to have to use my second camera for longer shots. So I guess that is the way it's going to have to work. So let's see, what else can I do? I have, this is my ALU. So I have this ready to solder up. Solder. It's pronounced like folder. So I can solder all this up. I wish there were a way that I could maybe I can move this light over a little bit, or like put it to the side maybe. It's a ring light, so it really goes over the lens. But the problem is when it goes over the lens like this, you can see the image basically of the light. So that's what it kind of looks like. So if I put it over the lens, I get glare. Obviously, I'm not going to get glare if I don't have anything shiny. But this side angle seems pretty nice. It's a little confusing though because, you know, there's going to be a shadow. Yeah, there is actually a shadow, but maybe I could use maybe two lights, one on one side and then one on the other. That's a possibility because I do have two of these tiny little lights. What happens if I just shine my desk light onto this thing? Well, same problem really. There are going to be shadows. So here's the desk light on one side, and here's the ring light on the other. It's still not very good. The shadows are reduced. It's just not extremely bright. Oh well, I guess if I don't spend $10,000 for a microscope, you don't actually get anything really high quality. So now this is the microscope that Strange Parts set up. So this comes directly from Shenzhen in China. And it comes with, this is actually exactly the same microscope as sold by Amscope, which is really funny. And this was like, you know, it was like $200, and Amscope sells these for, I don't know, $400 or $500. It's pretty funny. But the thing is absolutely identical to an Amscope microscope. Same color, everything. The only difference is the camera that comes with it, which I think is actually a higher quality, which is really funny. So if you want a reasonably good inspection microscope, get the one that Strange Parts has. That's what I would suggest. So yeah, the light needs a diffuser. Does it do selfies? Here, I'll put my nose under it. The light needs a diffuser. Well, it's got, no, it doesn't really have a diffuser. Let me put a piece of paper on it, over it. Let's see if that helps. Put a piece of paper where the glare is the most. So something like this. Actually, that's not half bad. That's not really that bad, yeah. Yeah, you're right. That was a good suggestion. So maybe what I'll do is I'll get, I don't know, maybe a piece of wax paper or something, and just put it on the light. So, okay, that's pretty cool. So anyway, yeah. So I can, I think, show soldering videos a little better than the previous one. The previous one was just absolutely horrible because the video just kept blowing out from the intensity of the light. So yeah, let's see if I can put a chip, just any old chip, and see how it kind of looks. Well, that's not too bad. It's not great in that there's not a whole lot of dynamic range, but it's kind of good. I can zoom in. Yeah, that's really not too bad. Okay, this is a pretty fine pitch part. You can see that that the pins are obviously, this is probably for an SOIC, and this is a TSOP. So probably this is 0.65 maybe, and this is 0.5 millimeters, possibly. I think that's right. Let's see. Yeah, so a rat in a tub says that they've heard that Ampscope provides nicer customer support. Honestly, I've never dealt with their customer support. I don't know what customer support you could possibly have for a microscope like this, except it's broken, can I return it? But for the price of this, if it breaks, I'll just buy another one. I mean, it's insanely cheap. And it's exactly the same one. The one problem that I did have, the one nice thing about Ampscope is that I ordered an inspection microscope that wasn't like this. I think it was actually a biological microscope. So I asked them to return it, and they said sure. So I returned it. How deep can it zoom? Pretty deep. Let's see. There's a via. Okay, that's about as far as I can go. Let me. Okay, so that gives you a sense of the scale of things. And if I grab my micrometers and just measure how big these pads are, let's see. Where's my micrometer pointing? Let's see. I guess you can't really see the display. Oh well. Each of these pads looks to be about 0.7 millimeters, I think. So let's see. Yeah, this pad right here. Oh, let me maybe try to measure the pitch. Maybe a little more than that, a little less. Yeah, that's about the pitch. Okay, the pitch looks to be 0.65 millimeters. So the video seems to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10 of those. So this is 6 millimeters across, about. 6 millimeters. That's not a whole lot. Let's see. 6 millimeters in American is about a 1/4 inch. So yeah, so this is about a 1/4 inch wide. That's pretty good. And you know, it's a binocular microscope, so if I'm looking through the microscope lenses, I can see this really, really clearly. Oh, here's something interesting. So this is the backplane. Let's focus on this. Well, let me zoom out to give a little more context. Yeah. So zoom. Let's focus. Great. Okay, so these right here are the signals for the backplane, and they all get terminated by a resistor and a capacitor. So these are resistor networks and these are capacitor networks. And if I zoom in on the resistor networks, if I zoom in maybe a little more, okay, so this is kind of neat. Where's my tweezers? Yeah, so here are the pads, and you can see that around the pads, that's not a shadow. That's actually solder mask pull away. It's basically where they mask off this green stuff. So it basically goes anywhere that this green stuff goes over, it's basically a coating. And then, of course, around the pads, you don't want that coating on top of the pads. So there's a certain distance away from the pads that they put basically a hole in this thing. And that's basically called the solder mask. And I can't remember whether the solder mask is the holes for the pads or it's the stuff around the pads. In China, they call this green oil. In Chinese, the translation is green oil, or green oil coating, or something like that. Anyway, so okay, yeah. So the important thing to the thing that was really bothering me is that this, I'll just call it the coating. The coating actually adds height to the board above the pad. So you can see that the coating, or the solder mask, I'll just call it the solder mask. So you can see that the coating is basically everywhere except where the pads are. So in effect, the pads are sort of inset into the board. So if I put a component on, let's see if I have one of these components lying around. Yeah, here's one. So if I put a component like this, now this basically doesn't have leads, even though it looks like it. It actually doesn't. Why can't I grab this? Okay. There. So if I... Okay. First of all, let me see if I can get that blob of solder off of it. Nope, not really. But if you look at it, so basically... Zoom out and focus on the component, if that's even possible. Yeah, it's hard to see from this angle. Maybe this angle is better. No angle is really very good. But anyway, the point is that there aren't any leads on this thing. So basically, the component has to sit flat. And in order to get soldered onto the board, it has to sit flat so that the solder can flow between the metal on the component and the pad. But if the component is sitting above the pad, that means that there's a gap between the metal and the pad, which is difficult for solder to bridge. Unless you put a lot of it on. So I was having a lot of problems soldering these components onto this footprint. So what I did was I ordered another board with a modified footprint that removes all of this mask, so that I can just take the component and put it flat on the board, and hopefully it'll be easier to solder. Yeah, and even with flux, it just didn't work very well. You had to go fairly slowly, and it wasn't very fun. So let's go back to the components. Got a model number for you. Okay, well, what you should do is you should go on YouTube. You can go now because this live stream is actually being saved, and you can always come back to it later. Go to the YouTube channel called Strange Parts, and go to any of the later videos and click on the More link in the description, and there will be a description of all of the equipment that he uses, including a link to the Alibaba store where this thing is sold. So yeah, so that's a really awesome thing. The only thing that I didn't actually like, and maybe this is the reason why this is so cheap, is it came with a very short stand. Now, I have the Microscope stand, which is actually an arm that sits up about a foot or a foot and a half above the desk, and it can move in and out, and it can rotate in several directions, in all three directions, actually. And it also allows you to, it's also got a really heavy base, so the microscope can actually sit almost 2 feet away from the base, and it'll still be balanced. The cheap one that I got from China, it kind of looks like you basically, it's almost like it was the base for a biological microscope. So you can't really get under the microscope to solder things, even though the guy from Strange Parts seems to not have that much of a problem doing it. Nevertheless, I like the increased distance that I get with the better armature. And for that, again, I'm sure you can get it from Shenzhen, but as Strange Parts says, people in Shenzhen often just don't have Alibaba stores. You actually have to physically go to Shenzhen to buy stuff. So I'm sure that if you live near Shenzhen, you could just go down and go pick up a microscope arm, and you're done. Unfortunately, if you can't do that, you probably have to buy it separately from Microscope. But in any case, I really like it. Let's see, how diffused are the LEDs? Well, I mean, they're point lights, right? They're point sources. And I guess they're not really that diffused. They're really bright. The ring light that came with the scope has a dimmer control on it, which is kind of nice, I guess. Of course, you can't really see it in the camera because the camera is going to auto-adjust. There is a menu on the camera. You can sort of see it here. Let me do this. So there's the menu. There's automatic white balance, WDR, HDR. I don't know what that is. Let's change it and see what happens. Manual. Manual 2, manual. Oh, okay. Well, I guess this is the automatic brightness control. So if I put something down and change the intensity. Oh yeah, all right. I guess that turns off automatic brightness control. So I can do that and change the intensity. Well, that's nice. Maybe I'll just leave it like that. So let's see what else there is. There's image effect. What's that? Oh yeah. Brightness, contrast, sharpness, definition, color gain. Yeah, I don't really want to mess with all of this. Hey, let's turn on the color bar. Great. Black and white, that's not fun. Vertical mirror, horizontal mirror, color gain, definition, sharpness. Yeah, I don't really want to mess with all that because, you know, I might just end up making things worse. Let's see, there's a cross line, which is kind of cool. So you can do a bunch of lines. Great. Line color, line width. Okay, that's intriguing. And then there's resolution. So there's a 16 by 9 or a 4 by 3. So if I change to 4 by 3, well, I guess nothing really seemed to happen. Well, 16, that's weird. Wait, 16 by 9 is just 4 to 3 squared, isn't it? Yeah, okay, well, whatever. There's the language. The camera came from the language. The camera came from Shenzhen, set for Chinese. So I actually had to stare at this menu, and then I think what happened was I recognized the word for Chinese. Yeah, I think it was set for simple Chinese. And then, of course, you notice that the menu doesn't change immediately. So I had to change it and then go down to what I thought meant save and exit. So eventually I figured it out. So that's pretty cool. Yeah, the automatic white balance worked pretty well. So anyway, kind of a nice little camera for the price. Insanely cheap. So yeah, this actually looks somehow nicer without the automatic gain being set. Let me see if I can get that other board with the chip on it. Where's the chip? Chip. That's not too bad. I think subjectively, at least, it looks better without the automatic gain. So that's cool. Yeah, wide dynamic range, high dynamic range. I think this camera has a pretty good dynamic range. It's not fantastic, but it's reasonable. And I think that's also the reason why the other camera was just sort of blowing out, because it was just too bright for it. I did notice that in the other camera that I got from Amscope, which incidentally does not make their own cameras, but they resell them from a company called TubeCam. I did notice that there was an automatic dynamic range control, and it would constantly adjust the contrast and the brightness to get the best image. And it was a good image. It's just that it only updated at like 10 frames per second. And this is, this seems to be doing about 30 frames per second pretty well. So again, I'm right pleased with this camera. The microscope, I'm glad I got it, even though it's identical to the one that actually it's not identical to the one that I currently have. The one that I currently have, the previous one, which I got from Amscope, was trinocular, except that in order to that there was a little lever which changed the light path from the left eyepiece to the trinocular camera. So it wasn't true trinocular, in that you could actually only have two light paths at the same time. This one is true trinocular. So I can look through the eyepieces in stereo and have the camera running at the same time. which is really, really nice. The adapter that the camera came with fits really well onto the trinocular head, which the tube cam cameras that Amscope sells do not. I was able to adjust the rotation and the focus, so there's actually a separate focus ring for the camera adapter, which is really great because I was having the worst time with the other one because whenever I would focus the eyepieces, the camera would lose focus. So, you know, it was basically bad all around. So again, I'm really glad that I got this camera. And it came pretty quickly from China. Oh, WDR HDR is wide dynamic range, high dynamic range. Ah, okay. All right. Yeah, let's play with that again. So, let's see, wide dynamic range, high dynamic range. So these are manual and this is auto. Yeah, so auto, I don't know. Yeah, I don't know. Auto to me just doesn't seem very good. I think just having it fixed actually works better. So, yeah, go figure. I don't know. So, save and exit. Let's see. Wonder how the Google Translate app would fare with such menus. Actually, the times that I've used Google Translate have worked out very well. I got some piece of equipment that I can't remember what it was, but the instructions were, oh yeah, right. New headlights for my car. And the headlights came from Japan, and the instructions were all in Japanese. Now, you know, you would think, well, it's headlights. How difficult could it be? But there were a few like connections that I didn't really know where they went or what they were supposed to do. So I just pointed my camera at the instructions and set it up with Google, and you know, took a picture and used Google Translate, and it worked out really, really well. The instructions got very easy to understand once they were in English, and it wasn't a bad machine translation either. It was pretty good. So I was really impressed. Okay, let's see. How about some insect anatomy using this? Well, this is the Bay Area. There aren't that many flying insects around here. So my house, believe it or not, has no flies, no spiders, no little, you know, flying gnats, no ants. I have no bugs to put under this microscope. So, sorry. Let's see. Is there anything small that I could put under the microscope? I have a chip. Let me put a chip under the microscope. You're not really going to see anything because for that, number one, you need a metallurgical microscope, and number two, you're not going to get any sort of reasonable magnification, but there is a chip. So yeah, that's about as far as I can zoom in. And it's, of course, very shiny. There. You can sort of see that there's obviously some sort of regular structure on this. It looks like there is 6, possibly 8 things on this. And I forget what chip this is because I decapped it and I don't know where the lid went. I must have taken a picture of this at some point. So it's probably on the website somewhere. It looks like maybe this is a hex inverter. No, it's got too many pins for that. Yeah, I forget what this is. Maybe it's an octal register. Sure, let's go with that. Yeah, anyway, that's about as far as you can get. So, for anyone who's interested, let's focus. You can see that these little wires here are the bond wires. They connect the pads on the die, which is this, to the lead frame, which is this around the edge. The lead frame goes to the pins. This is a ceramic package, not a plastic package, which is why it actually, why I could pop the lid off of it. And inside, you can see it kind of looks gold. I'm not sure if that's actually gold or not, but basically that is a ground, effectively. Let's see, something else that's interesting. So you can see on this side, right here, on the left side, there appears to be a pin that has two bond wires going to it. That is actually the ground, and it's got two bond wires so that it can take more current. Same thing over here on the right side. Here's one pad which has two bond wires going to it. So that's the other power lead. Actually, this is probably ground, and that's probably VCC if this is a TTL chip, because ground, well, actually, I don't know. I don't know which way I'm holding the chip, because it could go this way or it could go, the other way. But in any case, yeah, that's why you see two bond wires here and two bond wires here. So that's kind of interesting. Sometimes I've actually seen inside a chip a second tiny little die, which does actually nothing, but it connects to like ground. And that basically, the purpose of that is to ground the entire bottom section. So anyway, that's kind of fun. Let's see. I'll just leave that up here. Let's see, what else can I show? What else can I show? I have a GPS module. This is a GPS module. That's the antenna. That's the antenna wire. It's actually fairly small. Okay, what else have I got? Here's a relay. Yeah, that's not very interesting. It's kind of too big to put under this thing, but it's a relay. Oh, here's another relay. It's smaller. So you can see the coil inside here. And this is the little switch thing-a-ling, and there's the spring. And there's where I bought it, Weird Stuff Warehouse, which no longer exists because Google bought the property. Let's see, what's this? This is a big old diode. Here's a light, a lamp. Let's see. What else? Here's an LED inside the package. I don't feel like opening it. Well, okay, I'll open up the package. There's an LED. Let's zoom in on the LED. Okay, there we go. And you can see that little wire, that literally is a bond wire that goes to the LED, which is inside this tiny little area right in there. See if I can get maybe if I can bend the LED upwards, we can sort of see from the top No, that's, well, it's kind of hard to see because the top is a lens. Ah, well, yeah, that sort of works. There we go. There's the LED right in there somewhere. You can see the two bond wires connecting it. So, and it sits basically in a little reflector. And then the top of the LED is basically acting like a lens also. So that's kind of neat. Let's see. Let's go to the chat. Nothing new. There are 25 people watching right now. So I guess I better, 26 people. So I guess I better show something else. Let's see. Here's some desoldering braid. That's what that looks like. Let's bump up the light. Oh, okay. Well, desoldering braid. Okay. What else do I have? I have a breadboard. This was an abandoned experiment in something to do with a coil and a diode, so probably a switching power supply. And there's the chip. LM7840. Yeah, LM78S40. If anyone knows what that is, because I sure don't remember. It's probably a boost converter chip. So, yeah, there's the output filter, coil, along with some capacitors. I guess that thing over there is the switching transistor. There's the diode, and there is the coil that the energy comes from. All right. We can zoom in on one of these pins. That's what the inside of the breadboard looks like. So this is actually what separates cheap breadboards from good breadboards, is the wipers inside. So these two wipers on the inside, and I forget who did the teardown of the cheap breadboards versus the good ones. It was Julian Alette, right? Again, that channel is also pretty good. Julian Alette basically opened up one of these breadboards and looked at these wipers and saw that the ones on the cheap ones were really poorly made and not formed correctly to hold on to the components very well. So I bought my breadboards from Adafruit because really, if you do buy them straight from Shenzhen, you're going to get the cheap ones. And they're going to be the ones that are no good. They're really hard to put components in at first, but putting those components in basically bends these wipers out, and then the breadboard is no good anymore. So the breadboard is basically completely useless. So something I learned. Also, the other interesting thing is that the ones from Adafruit have the rails that go all the way across, while the ones that I get cheaply from Shenzhen have a break in the middle. So you actually have to have wires that go across. That's neither here nor there. The other thing that I saw from Shenzhen is that these numbers are basically just randomly placed in the cheap ones. You know, one will start up here, and and the scale won't even be right. So, yeah. When it comes to breadboards, pay the premium. Let's see, anything new in the chat? Yeah. Let's see. Are those bond wires lacquer dipped? No, they are not. They are not insulated. Do I prefer round pin or square pin jumpers? That is a really good question. I just use the square pin jumpers. I don't really use them in breadboards all that much. I know that you're not supposed to put the square pin jumpers into these breadboards. The square pin jumpers, I think, are really from the era of wire wrapping. And when you wrap a wire around, actually, I have some wire wrap. Why don't we do some wire wrapping? Okay, let me get my wire wrap stuff. All right, let's see. Let's see if I can actually put some of this stuff under the microscope. Man, this is such high magnification. Okay, so I guess you're just going to have to sort of imagine this. This is my wire wrapping tool. It's not an automatic wire wrapping tool. And in here, if I take this out, well, look at that, how cute. It's a wire wrap stripper. That's all it is. And basically, this is wire wrap, also known, I think, as Kynar, but you basically put the wire between these blades and then you pull. And there you go. There's the wire. Now, normally you would have more than that if you're going to wrap. So here I've done a bit more. Now, let me just grab one of these jumpers. Okay, so that's the square pin jumper. And the idea is that you take the wire and you wrap it around, and the wire, the corners actually dig into the wire. And it's a very reliable connection. So the idea is that then you take this part of the tool and you stick the wire in. There's a tiny little hole in there. See, and the wire comes out of that little slot thing over there. And you just sort of put it all the way in. I'm just, unfortunately, I think I bent the wire a little bit. And bending the wire will damage it. Okay, there we go. So now it's fully inserted into the tool. And basically the tool has a hollow end. And you take the end and you just insert it over the pin. And then you spin it like this. And you just keep doing that until you run out of wire. And there you go. It's wire wrapped. Okay, that wasn't very good. Oh boy, that was a horrible one. But, you know, I'm pulling on this and I can't pull the wire off. It's not coming out. Well, okay, so it's coming out, but it takes a lot of force. So here, let's remove the wire and try again. Maybe do a little better job this time. So I'll strip this. Okay. And now I'll put the wire in the end. It's a little hard to see. Okay. There we go. The wire's in the end. And I stick it on the pin. And now you have to get a little practiced at this. You can't push. You can't push down on the tool, otherwise you end up with that lump. There we go. That's how it's supposed to look. See that? It's nicely spooled. And you know, they used to make computers out of this. They didn't solder anything. They They just had very large pins, you know, sometimes three or four layers deep of these wires, and basically that was your. That's why they call it printed circuit board instead of wire wrap. So, so that was fun. Anyway, so going back to the difference between these square pins and the round pins. Yeah, the square pins, I believe, are damaging to breadboards, but, you know, I don't use them that often, so. Wasn't that fun? Let's see. Yeah. Well, okay. I mean, pin shape, it doesn't really matter. Again, you can stick them into your breadboard and they'll work just fine. I mean, after all, you know, all breakout boards come with a whole bunch of these, you know, breakaway pins. And everybody is perfectly happy to solder them on solder. Damn it. I'm falling back into my old habit. You know, you just solder these onto the breakout board and then you stick it into your breadboard and you're done. Again, you know, you're not going to be inserting these things and removing them and inserting them and removing them into your breadboard, you know, 100 times. That being said, if you do it 100 times, you're going to ruin your breadboard, and then you may as well just buy another breadboard. But if you buy the quality breadboard, then really that's going to be the least of your worries. So anyway, that was kind of fun. Let's see. I did actually have a practical use for wire wrap, and that is I had a sort of a kind of a board, except it was inside an enclosure, and it just had pins sticking up like this. And I didn't want to solder up a header. I didn't want to solder wires directly to the pins, so I just wire wrapped the pins, and it worked great. So yeah, wire wrap actually does have a niche use. So fun for all. Let's see. How about, can we look at a piece of paper? There's a printed piece of paper. Can zoom in on the dots. So that's kind of interesting. Zoom in a little more. Yeah, okay, since I turned off the this. There we go. I don't really want to leave it on that because that's too bright. So that's kind of fun. So that is paper, and it kind of looks like, I guess it was inkjet printed. That's certainly not toner. Toner is actually melted looking. Yeah, that's inkjet. Let me see if I can find something that I printed with my laser printer. I print a lot of data sheets because I guess I'm old school. So here is the equivalent that gets laser printed. So you can see it's a lot smoother. You can actually see the dots, which is kind of interesting. That must have been from the original file. In other words, the original file was you know, limited DPI. You know, these are sort of, these aren't really, well, these are vector graphics because they came in a PDF, and usually the PDF fonts are vector fonts. But you know, you can definitely see the pixels. So anyway, you know, you can sort of see that it's nice, clean edges. That's because toner is really just a powder that gets melted onto the paper. So that's pretty neat. Let's see. I think I now want to reduce the brightness. Okay, let's see. So, yeah. Let's see. And then there is something that I did with pen. Let's look at that. Okay, you can see that the ink sort of bled into the fibers of the paper. That's kind of neat. I actually use a fountain pen. I do not use ballpoint pens. So this ink is actually fountain pen ink. And it's a particular fountain pen ink that I found works really well on laser paper. And the only ink that I use is absolute super midnight black. You know, no... It used to be that black was actually having a tint of blue, but nowadays they've got this really good fountain pen ink stuff that's just like black, 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 super black. I like everything black. My car is black. My jacket is black. Okay, so do I have a good source to find female single header pins? Wow, yeah, that's a good question. I think the answer is just going to be DigiKey, but you're going to pay for it. What I actually did was I sourced, I think, a 40 by 1 female header from Shenzhen, with the idea that I would just break it apart. And you can break it apart. You'll ruin 1 or 2 pins, but so what? I mean, you've got 40 of them. So, you know, you basically just break it. You know, you sort of... let me put something interesting on the screen, rather than just looking at... here we go. Here, take a look at this resistor. So what was I saying? Oh yeah. So the header, you can break it apart. You'll break some of the pins, but you know, so what? You just score along, you know, score between the pins, break it, and then you just shave off the ragged edge, and you've got however many female pin header that you want. So that's what I do anyway. I guess because I'm cheap. I suppose I could buy a 1 by 1 female header from DigiKey if they have it. Let's see. What else can I put under the microscope? Here's an EEPROM. Anybody remember EEPROMs? So this is an AMD 2732. That's a 32K by 8 EEPROM, I think. Anyway, there's the EEPROM. You can see the drivers around the edge. Oh, yeah. Remember I was talking about a tiny little die that was away from the main die? That's this thing right over here. That's basically the substrate connection. Anyway, so yeah, you can see the drivers around the edge. These lines up here are probably the address decoders. And then this area over here is the actual data. That's where the data is stored. And no, unfortunately, with an EEPROM and with flash memory, you cannot actually optically see the bits. You can only see bits on ROMs that have fuses. So that is kind of unfortunate. But Oh well. So, zoom out. This was made in 1982. 23rd week of 82. Yeah, the famous 2732. I'm pretty sure this actually doesn't work. I did try programming it and it wouldn't program. I think because the programmer that I have doesn't attain the voltage that this needs. The really old ones, I think, required a programming voltage of 21 volts. And the programmers that you get nowadays just don't do it. This one's a Hitachi 2732. So anyway, you know, I keep these in case, well, I don't know why I keep them, honestly. I don't know why. They're kind of fun to have around, I guess. Let's see. What else? What else can I show? I do have the female headers that I was talking about. It's this. So you can see that the edges are broken and that this pin right over here is basically not usable, and this pin over here is not usable. Actually, the metal just fell right out. But there it is. There's a 7-pin female header ready to go. You know, you can just Dremel the edges down and basically get a perfect female header of exactly the right size. Not as convenient as the male breakaway headers, but you know, female headers are you know, they just take up more space, and you know, there's no room to have a little line where you could break them apart. So yeah, so that's something. Let's see. Okay, well, I guess that's all I really wanted to talk about. Really, I just wanted to, you know, try the microscope and, you know, see how it worked. And then I discovered that I couldn't actually find where in YouTube to set up a stream because they had changed everything. Now, I'm not change averse, okay? Change is okay, except when I need to do something and then discover that a change was made so that I don't know what I'm doing. And that's really stressful. So that's why I was kind of stressing out. And in the end, I changed YouTube from Creator Studio Beta to Classic. And then, you know, I knew exactly where to find the thing. So probably, you know, before my next live stream, I'm probably just going to do a live stream this weekend about soldering this ALU board together, just for fun. But, you know, hopefully by that time I will know where to find the streaming options and, you know, how to set it up properly. Because apparently I started 2 streams that, you know, just were either black or, you know, I didn't know what I was doing. So anyway, I guess that's about it. So I'm going to sign off right now. So bye.